start with the various aspects based on which the Rutherford's model was a failure. So there are many things, as I told you, which Rutherford's model could not explain based on few of these topics, and there are this few reasons why Rutherford's model were not able to explain such things. So the first one was, as we know, Rutherford's model told us that electrons was revolving around this nucleus. So if this is the nucleus, electrons would just revolve around this nucleus in a particular orbit, right? And this revolution would be provided by the Coulombic attraction. The centripetal force needed for this revolution would be supplemented by the Coulombic attractive force. Now, as we see that with this centripetal force, if these electrons are revolving, means that these electrons have a accelerated motion, right? And this accelerated motion, if they are moving like this, as we know, electrons are charged particles. So according to electromagnetic theory, as we know, if electrons would start to move, it would start to radiate. If it starts to move with a certain velocity, then it would start to, especially with accelerated charges, then it would start to radiate electromagnetic wave. So according to classical electromagnetic theory, this electrons that have this centripetal motion and they would start to revolve, then they would start to radiate this electromagnetic wave. And when they start to radiate the electromagnetic wave, generally they lose the energy. And once they start to radiate, and once they start to lose the energy, what happens? They must lose the energy and spiral around, and they must fall inside the nucleus. This is what was predicted. If Rutherford's model is true, if things are happening this way, then electrons should radiate, because they are accelerated charged particle. They should radiate electromagnetic wave, and they should, in the process of losing radiating the electromagnetic wave, they should lose the energy. And if they lose the energy, they would spiral and fall on the nucleus, and it would not take very small time. And in that way, then these orbits are not stable. It should not be stable according to Rutherford's model and the predictions. But what we see, electrons are continuously revolving in a very stable orbit, and therefore there must be some kind of discrepancy in Rutherford model, and it is not able to explain the whole thing. The second very important thing is, if it must spiral and slowly if it has to fall inside the nucleus, then its angular momentum of the motion of this spiraling and falling inside by losing the energy while radiating the electromagnetic wave, it must have the continuously changing its angular momentum. If it's angular velocity omega, and if angular velocity continuously changes, then the frequency also continuously changes. And if the frequency continuously changes, then this whatever it radiates, this is a continuous process. So the radiation that comes out, and thereby the spectrum that comes out, that has to be a continuous spectrum. But what we see spectrums that we get from atoms. They are not continuous spectrum. They are particular lines. The spectrums are lines. Spectrums, we will have a very detailed discussion on the spectrums. But here what we see, that in atoms we have the radiating light radiation that gives the electron to move from one orbit to another orbit, and this radiation must continuously change the angular velocity as well as continuously should change the frequency, and thereby the spectrum that we should get, it should be continuous spectrum. But what we see that the atoms show as not a continuous spectrum but rather a line spectrum. Line spectrum means the frequency changes from one orbit to another orbit is very, very specific. Only a particular frequency or only a particular changes happen. If that is happen, then only we should get line spectrum. But here what we see, if it spirals, the frequency should continuously change and we should get continuous spectrum. But it's not happening. It means that there must be some kind of discrepancy with the Rutherford model, and thereby with this discrepancy, this model did not sustain much, and after that came Bohr's model, which we will be taking up.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.